Welcome to Mimi's Math Channel. Today I'm going to demonstrate how to find density and population density using these two formulas. My suggestion would be to look for the units whenever you're reading a word problem so that you will know where to put your information. For instance, for density, it's usually going to have the word per, P-E-R, which tells you that it's going to be a combination of both the numerator's unit as well as the denominator's unit of measure. So mass per volume. Mass is usually going to be grams or kilograms, something like that. Volume, if it's a liquid, maybe milliliters. We've already learned that volume is measured in cubic units. So you're looking for something that's cubic. In terms of population density, it's similar to the density formula, except we're talking about people and we're talking about the area of land. So instead of being cubic units, you may see like square units. And then the top one, masses of people, that's how I typically remember it. So in example 1, we are going to use the density formula, the one that was in green, and just perusing through it, we want to look for numbers. And we see it specifically says that the volume is going to be 27,000. So volume starts with a V, so we know that that's going to go in our denominator. So we can go ahead and write that in. Then as I keep reading, I see that this boulder weighs 75,600 grams. It does not have the word per in it, so that tells me that it's probably mass. So we're going to go ahead and write that in the numerator. And again, keeping up with my units, this is grams. It says what will be the density. So that's what we're looking for. And that's going to be on the side by itself. If I put this in the calculator, and that's going to give you 2.8, keep up with your units. In the numerator, I have grams per cubic centimeters. So this is what I mean when I said density will usually have per in the word problem. Part B, we're going to use the same information. However, this time we're asked to find volume. I have to manipulate that formula though, because if I'm dealing with density on one side, but I want to find volume, the easiest way to do it is to swap the D and the V. So your formula will be, so mathematically what that will look like is I'm multiplying both sides by V. But when I do that, that doesn't give me V by itself. It gives me M by itself. I want V. So I would have to then go ahead and divide both sides by D, which leaves me with the same thing I just said over here. So that's how you find the volume. Now I'm going to substitute what I know. Well, I knew that the mass was going to be 75,600, and I'm going to divide this time by the density, which is 2.8 grams per cubic centimeters. What I notice is I have grams in both the numerator and the denominator, so they go away. And that will make sense because my units for volume should be cubic units, not grams. So to find volume, I'm going to take 75,600 and divide it by 2.8, which gives me 27,000 cubic centimeters. All right, so in part C, I again have to manipulate the formula. I'm going to multiply both sides by V. So I am left with mass is equal to D times V, so density times volume. I already knew that my density was 2.8. I have to keep up with my units, grams per cubic centimeters. But this time I want to multiply times the volume, which we said was 27,000 cubic centimeters. And what I notice is I can get rid of the cubic centimeters. And therefore, my mass is going to be 2.8 times 27,000, which is 75,600 grams. On to example 2. Here we're talking about people. We are using a variation of the density formula, but it's more geared towards the population. The density portion of the population is still over here, and I'm looking for the word per, P-E-R. It's equal to the number of people over area. So that's going to be like square mileage or something that with a square. Here's some information when it's talking about density. How do I know it's density? Because I see this word per. People per square mile. We see that we can go ahead on the left-hand side, type right in 11,842.02 people per square miles. And then what we're going to do is set that equal to, we see that we have square miles. Well, square means that's area. So So that's going to be in the bottom, which means that we're trying to find the number of people, because that's what it says right here. So now looking at our formula, what we're going to do is, in order to get the variable on the numerator alone, we would have to multiply both sides by this 227.63 square miles. What you do to one side, you have to do to the other. That's going to give us the number of people. What I notice is I can go ahead and get rid of the square miles. Multiplying this out, this is going to be approximately 2,695,599 people. For example, 3. Looking through my word problem, I have 320 BTUs. BTUs is a unit of measure. It's British thermal units. We don't see the word per, so we know it's not density. We don't see cubic, so it's probably not volume. More than likely, that's going to be our mass. So we're going to go ahead in the numerator and put 320 BTUs. Then we're going to keep going. We see here, well, that's volume. That's cubic. So we have 18 times 8 times 12. Once we multiply this out, that's going to be 1728 cubic feet. So we know that's volume. That's going to go in the denominator here. So by default, based off of what's given, we have to find how many BTUs per. There's that key word. So that tells us that we're looking for density. So if the D is already on the side by itself, you just divide the right-hand side. So once I divide, I am going to have a density of, rounded to the 4th place, 0.1852. So we had to multiply the BTUs by 30. And so that's going to give us 5.556. And then we also see that they're asking after 2 hours. So we're going to have to multiply this times 2. This represents the hours. And so our final answer, including the units, will be 11.1 BTUs per cubic feet. Please like and subscribe. Have an awesome day.